This question. So this question starts off basic. The second part's the hard part. Okay, anytime you do a word problem, I usually like to read it twice. The first time I start my drawing if possible, just to kind of understand what's going on. And then the second time I'm really trying to label things and figure out what it wants from me. In the textbook, it usually draws your drawings for you, which is kind of nice. And on your unit assignment, there's usually a drawing accompanying the question, which helps a lot. If there's not, then I would spend the first time reading through doing the drawing. Okay. So when I read this, it says Carmen is a surveyor who is using a transit to determine the height of a tree. A transit is just like one of these little stand things. The transit is placed 52 meters from the base of the tree. You can see that they have drawn a line here, 52 meters from the base of the tree. And the angle to the top of the tree is measured at 12 degrees. 12 degrees, they've even drawn it in for you, which is nice and beautiful. Part A. If the transit stand is 1.8 meters high, which they haven't shown you. 1.8 meters high, that means this thing is 1.8 meters high, like that. Calculate the height of the tree to the nearest tenth of a meter. Awesome. Looking at this picture, you will notice there's a triangle highlighted in yellow right here. Across the bottom, straight up, straight down. They've given you a triangle. We can use that triangle to figure out the height of the tree. The height of the tree is this side right here. If you also look at our triangle, you'll notice it doesn't cover the whole amount of the tree. Right? There's this little gap right here that isn't a part of the tree. That gap is the same gap right here. The height of our little transit machine. So that's why they told you about the 1.8 meter high thing. Because what they're telling you is this little chunk of the tree is 1.8. This chunk up here, you don't know, you have to calculate it. And then you're going to have to add your two results together, right, to figure out the total height of the tree. So that's why they gave you that like little piece of information. Sometimes it throws people off when they get info. They're like, I don't know why they would tell me that. Like, what's the point? That's the point. Like in our picture, they're giving you the very bottom part of the tree. You figure out the rest. Awesome. Let's figure out the rest. So I've called it X up there. To figure out the height of the tree, I'm going to have to either use Sohcahtoa or Pythagorean theorem, right? I'm looking for a side length. It's always one or the other. To use Pythagorean theorem, you need to know two sides. If I look at my yellow triangle, I do not know the other two sides. That means I need to use Sohcahtoa. Right? To use Sohcahtoa, you need an angle and a side length. If I look at my yellow triangle, all I have is an angle of 12. I do know the bottom side length. They told me it's 52. Now I have a side length, I have an angle, I can do Sohcahtoa. Awesome. To do Sohcahtoa, you have to label your triangle properly, right? That's opposite, adjacent, hypotenuse. Across from the angle you're working with. So across from 12 degrees over here is your opposite. Your longest side across from the 90 is your hypotenuse. And the third side is your adjacent. So we labeled our triangle. We then write out Sohcahtoa. And we put a little check mark underneath each letter. We put a check mark under the S, the C, the T for free. Free spaces. Then we put a check mark under the side we know and the side we want to know. Looking at this triangle, I know the adjacent is 52, so I put a check under A for adjacent. I want to know my opposite, because that's what the height of the tree would be, the opposite side, so I put a check under O, and one of my things will have 3 checks. In this case, TOA. TOA means that for this question, you need to use the tangent ratio, so the t stands for, And the tangent ratio equals the opposite side divided by the adjacent side. So let's set that up. So we've got tan of an angle, 12, equals my opposite side, which is x, divided by my adjacent side, which is 52. That's how you set up your ratio. To finish this thing off, you need to get x by itself. To get x by itself, you need to move this 52. You move that 52 by multiplying it to the other side. This part goes in your calculator. When you put that in your calculator, you will figure out the height of the tree. And we're going to round to the nearest tenth of a meter. That means the first decimal place. So 52 times 10, 12, 11.1. It was 11.05 is what I got. Right? 0.5 would round to 11.1 because 5 rounds the next thing down. Awesome. Sometimes the trick with trig is that your answer is not the answer. Right? So for instance, we just solved for x. X is not the answer to my word problem. The reason x is not the answer to my word problem is the word problem asked me for the height of the tree. I did not calculate the height of the tree. I calculated x, which was this side of the triangle. It was a big chunk of my tree, but it wasn't the entire tree. Right? This chunk is 11.1. This chunk is 1.8. If you wanted to calculate the whole height of the tree, you would add those two together. So 11.1 plus 1.8 tells me the true height of the tree is 12.9 meters. That's the height of the tree. So just make sure with word problems that you're answering the question. Actually, a strategy that I haven't used before until recently is that you should underline what the question's asking you. Because in math, it's not always obvious what it's asking you for. Sometimes the question's at the end of the statement, sometimes it's at the start of the statement, sometimes it's right in the middle, right? And people are like, I don't even know what it's asking me for. So in the question, it's probably smart to underline whatever it's asking for, right? Calculate height of the tree. Especially with the word problems, because it's usually not your actual answer. You calculated something, but that just helps you answer the question. Awesome. I'm going to try to do part B without absolutely butchering this picture, because it's a little bit tricky to draw. It says, determine the angle of the base of the transit makes to the top of the tree. So, if you look at our beautiful line over here, you will notice that their angle of 12 degrees connects to the top of the transit, the top of the stand. What they're asking you is determine the angle, the base of the transit. The base means the bottom of the thing. What they want to know is if you drew a line from the bottom of the transit, I'm just going to put it right there, to the top of the tree. Good luck. Oh, that's not that bad. What angle would it make? That's what they're asking. So I've done it in the red there. I'm just going to erase a couple things here so that it stands out a little nicer. Let's get rid of my word Jason. Let's get rid of my 52 in there. So you see I've drawn that red triangle now. That's the triangle you're now working with. And you're looking for an angle, we call it angle X, right in there. Everybody see that triangle? Yeah. I didn't butcher it as bad as I thought I was going to. It's not that bad. I kind of actually got somewhat to the top without messing up. Awesome. The only way that we know how to solve angles is if you know the other two angles, which we don't, or Sohcahtoa. Alright, so when you get a question where it's asking to find an angle, check to see if you know the other angle. If I knew the other angle up here, it would be really easy, right? It's that 180 term, 180 minus the other two. If I don't have that, which 99% of the time I don't, then I'm going to use Sohcahtoa every single time for finding a missing angle. Awesome. To use Sohcahtoa, you need to label your sides. Opposite is across from the angle we're looking for. Adjacent is down here. It's the 52. And my hypotenuse is this new line that I drew across. Fantastic. The opposite side is the side of the tree from top to bottom. Right now I'm actually drawing this triangle all the way from the bottom to all the way to the top. You have to use your answer in part A to be able to do part B. This entire side length, the height of the tree, we just calculated is 12.9. Right, that's the whole height of the tree. Awesome, we now have our triangle set up. We have two side lengths, right? We have 12.9 and 52. That means we're going to use Sohcahtoa. To use Sohcahtoa, I labeled my sides. I got opposite over here. I got adjacent down here. I got hypotenuse up there. I'm going to write out Sohcahtoa. When I write out Sohcahtoa, I'm going to put check marks under things. I'm putting check marks under things I know and things I want to know. For this question, I'm going to not be able to see the picture and that. Sad moment. So I write out Sohcahtoa. I put check marks under the things I know. I know S, C, and T, they're free. I know my O. Whoa. Really didn't like it. I know O and I know A. So if I check under O and A, again, we find that we have the tangent ratio, which usually makes sense. It's usually the same one. That means I'm going to go tan of my angle. I don't know my angle, so I put X equals opposite, which is 12.9, the height of the tree, divided by the adjacent sides, which is along the ground. That's 52. That's how your ratio should set up. Okay, the number right beside tangent is what you're looking for. That's the angle. Who remembers how to find the angle? Get X by itself in this case.
Divide by tan. Get the X by itself.
Yeah, you gotta somehow get rid of the tan, right? And the opposite of a tan, we do that like little -1 guy, right? We call it inverse tan. Right? On your calculator, it's second and then tan. Right? The way it looks mathematically is we do this. Tan -1, like that. When we do that type of tan, the fraction and the angle switch spots with each other. So now I have 12.9 divided by 52 equals X. This thing can now go in your calculator because X is by itself. To do that in your calculator, I call it second tan. Right? So on your calculator, you have that second button up here in the top of the corner. So you turn your calculator on and go second, tan, then put this fraction in the brackets and enter. Has anyone done it? Did you get
13.9.
13.9? And that seems like a logical answer to me. Like my other angle was 12. 13.9 is pretty close. We're going to round to the nearest degree. So we would say it's 14 degrees equals X. I'm just going to scroll that down so you can actually see the math there. The angle, the base of my stand next to the top of the tree is 14 degrees. Awesome. Word problems. They're not that bad, right? We've even done a couple leading up to it, so it's not that crazy. Awesome. Any questions about that tree question before I move on? Okie dokie. This next one's a little weird. I don't really like it. I think it depends on things that you, from other units and other lessons from previous years, which is why I don't like it. Anyways, we'll read it. I'll show you how it looks together. So it says, a circle with center C and radius 20 is tangent to the arms of angle POQ. See, that's why I don't like it. Anyways, if angle POQ is 50 degrees, right, I'm going to label that POQ. That means if you go from point P to point O to point Q, P to O to Q, you create an angle. Or it's just the middle letter, right? However you want to look at that. 50 degrees. Determine the length of O to C. All right, to determine the length from O to C, we're going to have to sketch that in here. C is right here. O is right here. That length is what we're looking for. And you'll notice that it cuts that thing. And it cuts that 50 degrees. So we're not going to be able to use that 50, but we will use part of it. Awesome. If you look at that, it's like there's no right angle triangle anywhere. And that's what makes this question kind of challenging. So people look at it like, there's no angle. I can't use that at all. All right. This part right here is why I really don't like the question. Radius of 20. Does anyone remember what the word radius means? From the center of the circle to the outside, right? So that means if I went from here to anywhere on the outside of the circle, it would be 20. That's how we're going to create our right angle triangle. We're going to take this and we're going to go straight down. And when we do that, that's 20.
Does that actually connect, or is that important?
We're going to say it connects. It actually has a little gap there, right? It does. Like, there's a little smidgen of a gap in there. We're going to pretend it connects. We're going to pretend a couple things to make this question work a little bit easier for us. Okay, that's the first trick, is putting that 20 in there. The other trick would probably come from doing a little bit of witchcraft with our circle geometry. So remember circle geometry from grade 9. We're not going to do any of that business because you're never going to get tested on it again. So what we're going to say is that when this purple line came out, we're going to say it cut that angle perfectly in half. Like one of those isosceles triangles. Remember how we did that? So we're just going to say, hey, if it cuts it like that, it cuts it in half. So that'll be our unwritten rule. So if you have a question like that, just split it in half. That means that this right here isn't 50, it's half of 50, it's 25. Fantastic. You now have a triangle, right? And like I've said, no matter how hard this unit gets, always try to find a way to make a 90-degree triangle and then just start working inside of it. They wanted you to determine the length of OC. Length of O to C is my purple line. I'm going to call it X. I notice I have a 90-degree triangle. I notice I have a side length. I notice I have an angle. That tells me I should do Sohcahtoa. When you do Sohcahtoa, you put check marks under S, C, and T. And then you put a check mark under the side you know and the side you want to know. To be able to do that and to be able to use Sohcahtoa, we had to have labeled our triangle properly. Looking at our triangle, across from the angle you know is opposite. Across from the 90's hypotenuse. Other side is adjacent. Awesome. Looking at this guy, that means I'm checking off O and H. I check off O and H. I notice that SO has 3 checks. That means use the sine ratio. That means sine ratio is opposite over hypotenuse, right? That's what SO stands for. It's telling you your formula. Sine of an angle, 5, equals opposite, which is 20, over hypotenuse, which is X. This guy's a little bit trickier, right? So when X is on the bottom, that's when you have to do division. So I move my X to the other side by multiplying it over here. And then I divide by sine. That's the math behind it all. Some of us have just memorized. If x is on the bottom, you divide by it. So in your calculator, you need to put 20 divided by sine of 25. And that will tell you what x is, because x is now on the other side of the equal sign all by itself. X equals. Has anyone done that calculation for my batteries at? 47.32? Yeah? People agree? Those kids are not. So that'd be 47.3. Not bad, eh? I hate that question just because I think the setup of it's really ugly, and I think it depends on things that you're not good at. Nothing you're not good at that are unfair for you to be dependent on remembering radius and tangent and circle geometry. And I feel that's unfair that you have to know that stuff to be able to do the trig question. And so you won't see a question like that on a test, at least not one that complex. Right? But at the end of the day, all you do is build a 90, right? You start labeling things, and it'll always work. Awesome. We're going to do one more in this one, and then we're going to switch down to the next lesson and look at some harder triangles. Class example 3. In the diagram, the man on the ground is standing 12 feet from the wall. All right. You got a man standing from a wall. The angle of elevation from his eye level to the level of his wife in the building is 62 degrees. You see him down here, you see his wife up there. If the man's eye level is 6 feet above the ground and his wife's eye level is 5.2 feet from the top of the building, determine the height of the building to the nearest tenth of a foot. So, I read questions twice. The first time I read them, I try to do somewhat of a picture and try to just understand what's going on. They've done the picture for me. I've got a dude, he's looking at his wife in the building. Right? That's my general consensus of what's going on. The second time I read it through, I'm going to try to label that picture. In the diagram, the man on the ground is 12 feet from the wall. Okay, looking at this, I've got a guy, there's the wall, he's 12 feet. That's from him to the wall. Actually, I'll even do this. You can connect the dots. Awesome. The angle of elevation. Elevation means the angle going up from a horizontal line. Right? So if you're thinking about me looking, right, and you draw an imaginary line straight over my face, if I went up from that horizontal line, that's elevation. If I went down from that horizontal line, that's depression. Okay? They always connect to a horizontal line. The angle of elevation from the eye level to the eye level of his wife. So from him looking up to his wife, they've even labeled elevation for you, is 62 degrees. 62. And they labeled it for you. They labeled angle of elevation, which is pretty nice. Awesome. If the man's eye level is 6 feet above the ground, that's kind of like the trick we did on the last question, right? They're telling me from here to here is 6 feet. And his wife's eye level is 5.2 feet from the top of the building. That one's a little trickier. They're not saying she's 5.2 feet tall. They're saying the distance from the top of the building to his wife's is 5.2 feet tall. Determine the height of the building to the nearest tenth of a foot. So what I need to look for is the height of the building. The height of the building goes from here all the way down to here. And you'll notice that within that, there's chunks. There's the 5.2 chunk, which is from the top of the building to the left. Then there's a really big chunk right here, which we don't know. And then there's another chunk right here. This bottom chunk is the same as the height of the man, which would be 6. So if you're looking at this question, it's kind of like the tree question, right? Where you've got chunks to a length. Within that, there's a triangle. You need to solve that chunk to be able to solve the entire question, which would just be adding 3 pieces together to figure out the height of the building. It's the same thing as the tree question. It's just a little more complex. Looking at this question, I know one length of my triangle is 12. I know my angle is 62. I'm looking for x. I want you to try to label your triangle properly using Sohcahtoa, pick the right ratio, and then answer the question. All right, so give it a shot on your own. I'll show my work up here on the board, so if you want to check along in stages, feel free, but don't just copy down what I put down. Okay, so, but give it a shot. See if you can figure what x equals and then what the height of the building is. Oh, didn't do that. Okay, so I labeled my triangle, right? I had to label for Sohcahtoa, like I said. Looking at my triangle here with my building, the building is opposite along the ground. The 12 would be the adjacent. The hypotenuse is that line connecting their eye sites. We're trying to find opposite. We know adjacent. When I do my pre-checks, that should have got me the tangent ratio. When I use the tangent ratio, I went tan of 62 equals opposite over adjacent, like I set that up right here. 12 was on the bottom, so I multiplied 12 to get to the other side. I put 12 times tan of 62 in my calculator, and I got 22.6. Awesome. It was 22.56. Right? So 5, 6 rounds to 6 up, and 1 more.
We're supposed to determine the height of the building.
Right. So that is not the answer. That is a chunk of the building. It's from here to here. They wanted the whole height of the building. We just need to calculate that chunk of the building to be able to calculate the whole height of the building. Now looking at this, the very top part of my building is 5.2. From here to here, 5.2. We then have this gap, which we just calculated as x, which is 22.6. And then we have this gap along the floor, which is the height of the man, which is plus 6 more. The actual answer to this question would be these 3 things added together. I think when you do that, you're going to come out to have 33.8. You guys are trusting my mental math for your learners. Is that okay? People nodding their heads. Beautiful. Just make sure you answer the question, right? There's nothing worse than being able to do all the math and then just forgetting what the question asks, right? And saying, oh, x equals 22, done. Our Math 30-2 class, we just had a quiz, and we marked them, and the question was like, how fast is the plane? And then during the question, x is the speed of a different vehicle, like a car. And everybody gave me the speed of the car. Right? They would go and they answer the question, and they go, oh, x equals 12, done. And they no, that's not the question, right? The question was, what's the speed of the plane, not the car. In this question, it's not what's x. X is just a chunk of the building. The question was, what's the whole building? Right? Make sure you answer the question. Awesome. The next part of the textbook goes through something called bearings. We're not going to do anything with bearings. Bearings is just a way of measuring like how to move, which way you're facing, right? If you hunt or you do anything in the wilderness, really, you probably talk about bearings. Okay, it's always based off of north being 0 degrees. So if you're facing straight north, that would be 0, and every time I turn to the right, like that's a new bearing for me. We're not going to calculate with it, but I just think it's an interesting thing and probably a good thing in life for you to maybe understand a little bit about. Okay, we won't really talk about it because we don't have the time. But if you're ever interested, it's kind of useful. How many people use bearings, like in hunting or something like that? Yeah. Do you hunt?
No, I don't like that.
No.
I just use bearings.
Use bearings to move around. Yeah, that makes sense, right? There is another way that we do this too, but I mean, that's for another day. Kind of cool stuff. So if you see any question that uses bearings, talks about, it should say the word bearings, but even if it talks about north, east, southwest, there's probably a good chance you don't do that question. Hey, just scrap that. Awesome. What we are going to do, though, we're going to scroll past all this on to the next lesson, which is just more problem solving. And we're going to look at questions that I call double triangle questions. Okay, so they're not really word problems. They're just challenging problems. My computer has decided that it's done working for a bit. I'm just going to give it a minute. It's a little cranky. When we get to the questions, you'll see what I mean. It means you have two right angle triangles. What page is that? 249. You should be on page 249. There we go. Peter likes me again. You'll notice you have questions like this. Okay, so I call them double triangle questions because there's always two 90-degree triangles within the picture. Sometimes there's even three. And I'm going to draw the different triangles in this picture. So if you're just looking over here, there is three triangles there. Okay, the first triangle is if you go all the way around the outside. All the way around the outside, the purple triangle I drew there, is not a 90-degree triangle. It looks like it's pretty close to one, but they haven't labeled it as a 90-degree triangle, so we cannot assume it's a 90-degree triangle. Remember, we can't do really anything with triangles that are 90 degrees. The only trick that works on a triangle that's not 90 degrees is the 180 trick. That's it. Right? Otherwise, we can't do anything. Pythagorean theorem doesn't work, Sohcahtoa doesn't. So this purple triangle is pretty useless to us. The other triangles that are in here, if you went from P to R to S, you would create that yellow triangle. That yellow triangle is a 90. They've labeled the 90 down here, so it's 90 degrees. The third triangle is this little guy right here. Right? So you have two 90-degree triangles that have their backs beside each other. With these double triangle questions, try to figure out where the two triangles are. The two 90-degree triangles. Sometimes it's obvious. This one's decently obvious. Sometimes it's not obvious. Alright, so try to always see if you figure out where the two 90-degree triangles are. The other triangles, don't worry about. Fantastic. Okay, I'm just going to erase this quick. And then we're going to talk about the trick to the question. I think the trick to the question, and it's up for debate, I suppose, is that if you look at your two triangles, they almost always share something. Well, that's about as good as it gets, folks. I don't know how long my game, I guess. So we got those two triangles, the red and the purple one. Try to make them brighter colors so you can see them. You should notice that they share something. Whatever they share is almost always the key to the question. In this case, they share a side length. They both use this side. So no matter what the question is, if I can identify what they share, that's usually going to be the key to the question. Alright? So let's read the question now and see if that actually holds true. Reading these double triangle questions is also a little tricky. In the diagram, Q to S is 32. So I look over here, from Q to S is 32. Here to here, 32. Angle P to Q to S. So angle P to Q to S. The middle letter, right, is usually what it is. But that means if you go from P to Q to S, the angle you make right there, that angle is 50. an angle R to P to S. R to P to S. This angle right here is 61. Use this information to determine Q to R. Looking over here, Q to R. Well, I'm going to highlight that in blue so it really sticks out. That's not blue. That's blue. Q to R. That's what we're looking for. What we look for, I call X. Fantastic. All right, that's a lot of info in there, right? And it's confusing and it's all jumbled together. The trick to these questions is remember that you can only work with 90-degree triangles, and that whatever they share will probably help you. So, for instance, if you look, Q to R is part of that big triangle that's not 90 degrees. I'll give you a hint. There's no way you can solve Q to R in one go, in one calculation. Instead, what we're going to do is kind of what we did with the building question and kind of what we did with the tree question is we're going to chunk it out. Right? If you look from Q to R, there's two little chunks. There's the one that's 32, which is already labeled, S to Q. And then there's this guy on the purple triangle. We call it Y. From R to S. If you could figure out those two little chunks and add them together, that would give you the big chunk of X. People see that? It's just two lines broken up. And those two lines happen to be part of our two 90-degree triangles, the red triangle and the purple triangle. And we're going to keep working our way backwards. So now that we know we can take the big line, break it up into two lines, now we've got to figure out how to calculate those two small lines. If I look at my purple triangle, I do not have enough information to calculate a side length. I know nothing. And I look at that purple triangle, all I have is one angle, 61 degrees. I don't know either of the other sides. However, they share a side, right? And the shared thing is almost always the key. So if I look, I've got this shared line that goes to the center. If I use my red triangle to solve the shared line, then I could use that shared line in my purple triangle to solve the bottom line. It is like a big loop that all kind of connects. And I think if you start with like what you want and work your way backwards of how to get there, it'll help. I know I can't do Q to R in one go. I realize, hey, I can chunk it out. I can't calculate that chunk right now. I don't have enough info. Hey, I could use the other thing to get that info. Right? And just keep solving your problems and working backwards. So this starts with finding the shared line from P to S. To solve P to S, you would need to do the red triangle. You need to label your red triangle. So opposite is over here, adjacent is down here, hypotenuse is there. You're going to do Sohcahtoa. When you do Sohcahtoa, you end up doing tangent of 50 equals opposite, which we don't know, divided by your adjacent, which is 32. I multiply my 32 over. I have 32 times tangent of 50 equals my opposite side. I punch out my calculator. I know my batteries are low. Just keep working. I get 38.1. And it keeps going, 1361149.6. And you should use that whole number so they don't make any sort of rounding there. Awesome. I just figured out that from P to S is 38.1. I now know this side length. looking at my purple triangle, what that means is I now have an angle and a side length. Now that I have an angle and a side length, I can do Sohcahtoa on the purple triangle, the one on the left over here. Using Sohcahtoa, I can figure out from R to S. You have to label the purple triangle. Okay, I know that we've already labeled this side length opposite, but that's when we were talking about the red triangle. When we look at the purple triangle, that side actually turns into the adjacent. Because we're using a different angle now to label this. So opposite is over here, adjacent beside it, hypotenuse across from it. So relabel your triangle when you use a new triangle or a new calculation. I'm going to do Sohcahtoa. I'm going to end up with tan of 61 equals opposite, which is y, divided by adjacent, which is 38.1. You should use all those decimals, right? You shouldn't double round. I can't. My calculator will let me. It dies every 5 seconds. So I don't have all those digits and don't have time to type them in, but you definitely should. You're going to multiply the 38.1 over here, right? So you have 38.1 times tan of 61 equals y. I'm going to try to sneak that in. 38.1 times tan of 61, and I get 68.7. I now know this chunk along the bottom, from here to here, is 68.7. The question wanted the entire length of the bottom, from R all the way to Q. That means you're going to have to take your two side lengths, your 68.7 and your 32, and you're going to have to add them together. 68.7 plus 32 will give you your answer, which will be 90.7.
107.
Thank you. I didn't carry a number. I don't know if you witnessed that, but I just wrote the same wrong answer twice. I mean, I got this answer. 100.7 would be the full distance, right? Make sure you're answering the question. Those double triangle questions, I think, are the hardest ones because it's really tough to logically figure out how you're going to get that answer. And that's kind of the beauty of math, is that it works on that logic side of your brain. Okay? How am I going to figure out this entire chunk when all I know is these little pieces? Right? Connect all the dots to figure it out. There's one more here. Calculate the measure of B to E to C. BEC is this guy right here. You'll notice that it's part of a big triangle that's not a 90-degree triangle. However, I could break it into two chunks. I could break it into that chunk right there, which is part of a 90-degree triangle. And I could break it up into this chunk right here, which is part of another 90-degree triangle. I'll call one of them X, and I'll call one of them Y. If I added X and Y, it would give me the entire angle B to E to C. I want you to just try to calculate those two chunks. Alright, the blue one's probably a little bit, oh, sorry. I've set you up for massive failure if I make you do it that way. can you do it that way? You can do it that way. There's an easier way through it, though. Is there? Or isn't there? Yeah, that's the other way is easier. Okay, if you did it that way, if you broke it into 2 chunks, and I saw people nodding their heads like, yeah, I get that. And then I'm like, oh, no, don't do it that way. You wouldn't be wrong. It's just there's a quicker way. Okay, so like that would take a little bit of work. You'd have to use this triangle on the right, the blue side, figure out the middle line, then use that to figure out x, okay, and figure out your 2 angles. But there actually is an easier way, I think, so I'll show you a different way. The easier way is understanding that in a triangle, all 3 angles equal 180. And they've given you this angle. If you figure out that angle, you can figure out the third one by doing the 180 trick. So even though it's not 90 degrees, the 180 trick works. Does that make sense? I said that earlier and then I forgot about it. Now, you need to try to use these triangles to figure out this missing side first. I'll call it y. If you can figure out that missing angle, then you can do the 2 trick, the 180 minus that 2 other trick, to get a third one. You're going to have to use the right angle triangle on the right side to somehow figure out the angle over here. Okay, give it a shot. I'm going to go through it step by step. We'll take our time. But I want you to actually try the recording. I made a mistake. It says B to E to C. That means B to E to C. This angle right here. So I was trying to make you figure out that big angle. You actually need that little chunk, which makes the question even easier. Right? So it just keeps getting better for us. So we don't even need to try to figure out another angle to do our 180 trick. You just have to figure out this guy right here. Again, I'll call it that. And B to E to C, which is straight down. I read the question wrong. I read it as B to E to A. Awesome. Keep going. Remember the